Imagine if atoms could talk to each other, like people on a telephone. That's exactly what scientists in Australia have just achieved. For the first time, nuclear spins, the quietest, cleanest quantum objects in nature, are now able to chat across a silicon chip. This breakthrough could change everything about how we build quantum computers. Quantum computers aren't just faster versions of today's laptops, they're a whole new species of machine. Instead of bits that are 0 or 1 quantum bits, qubits can exist in superpositions, holding multiple states at once. This makes them insanely powerful for solving problems like drug discovery, logistics, cryptography, and simulating the universe itself. But there's a catch. Qubits are fragile. They need to be isolated from noise, but still able to interact to perform calculations. Balancing those two demands has been one of the hardest problems in physics. Researchers at the University of New South Wales have focused on a unique type of qubit, the nuclear spins of phosphorus atoms inside silicon. Why nuclear spins? Because they are unbelievably stable. In fact, the UNSW team already showed they can hold quantum information for over 30 seconds. That's an eternity in quantum time. But here's the problem. These nuclei are so well isolated they can't naturally talk to each other. Imagine brilliant geniuses locked in soundproof rooms, perfect thinkers, but completely cut off. This is where the magic happens. The UNSW team figured out how to connect those isolated nuclei, using electrons as quantum telephones. Electrons aren't just tiny dots. In quantum physics, they spread out in space. That means an electron attached to one nucleus can also reach over and interact with another electron nearby. By coupling each electron to a different nucleus, the team made two atomic nuclei, 20 nanometers apart, talk to each other. For perspective, if each nucleus were a person, they'd be as far apart as Sydney and Boston, yet still holding a crystal-clear phone call. 20 nanometers doesn't sound like much, but it's the same scale at which modern silicon computer chips are already built. That means this breakthrough isn't just a physics experiment, it's directly compatible with today's trillion-dollar semiconductor industry. In other words, we could one day build quantum processors inside the same factories that make your phone's chips. That's the dream. Scalable industrial quantum computing. By removing the requirement for nuclei to share the same electron, UNSW solved the biggest roadblock to scaling this tech. The next steps? Add more electrons as wires to link many nuclei. Stretch electrons into elongated shapes to reach even further. Build complex architectures where entanglement, that spooky quantum connection, can spread across entire chips. This research doesn't just push the frontier of physics, it shows us a roadmap. Quantum computers won't be built in futuristic alien labs. They'll be built with the same silicon technology we already use, just pushed into the quantum realm. It's like teaching atoms in your phone chip to whisper secrets to each other. Secrets that could unlock the future of computing, medicine, and science itself. From soundproof rooms to quantum telephones, this is how the smallest objects in nature are learning to talk. And if atoms can have conversations today, tomorrow they might be holding entire debates, calculating solutions to problems humanity can barely imagine. So what do you think? Will quantum computers become as common as smartphones, or will they remain tools for scientists and superpowers? Let us know in the comments, and don't forget to subscribe for more stories on the breakthroughs shaping our future.